Hi everyone, good morning. My name is Danielle Aminov. I'm a threat researcher from Wiz, and I specialize in helping organizations map their external attack surface and help defend against threats in the cloud. And together with Yara Shriki, which unfortunately couldn't be here today, we investigated a major blind spot in cloud security. We all trust our external scanners to detect risky exposure in our environments. But what happens when access denied doesn't actually mean you're safe? Let's examine some real-world scenarios. So how many times have you heard in the past year about massive data leak in big companies? Probably a lot, because I did. So just imagine you read this in the front page of the Washington Post about this massive data leak in this big XYZ healthcare company in North America affecting you and your loved ones. And have you noticed that in many of the data leak reports, it says that it was originated by a compromised key or an account takeover, and some may say that also it was unclear how the compromise happened. So just think about it. This is the security issue I want to talk to you about today, laying in this area of blind spot where organizations struggle to map the origin of the compromise. So the agenda, we'll have the background and the motivation and why we even started this research in the first place. We'll have the misconfiguration deep dive, the scanning methodology, so you will be able to reproduce the scan on your own. We'll have the findings and the takeaways. Some of them are really quick and easy ones you can start ship today. Okay, so here what kicked it all off. As part of our work, we came across a leak secret that was used by an attacker and was originated in an S3 bucket. So naturally, we wanted to access the bucket and see if we can retrieve the same leaked key. So we did so, and the bucket retrieved 403 for maiden message, indicating that we don't have enough permissions to access to it. And the second attempt of access, we thought to ourselves, why don't you access the bucket while authenticated to AWS? But to our account, maybe that would work. And it did. This time the bucket changed the response to 200 OK, and we were able to both list and get objects from the bucket, including the leaked secret. And that just got us thinking, how many more buckets out there exposing sensitive data and are misconfigured in that way? So we started to investigate. But wait a minute, what just happened? What is the misconfiguration here? So the misconfiguration here is actually that the S3 bucket allows you to access to it while authenticated to any AWS account. I repeat that. So the S3 bucket allows you to access to it no matter what account you're logged into. So from an attacker perspective, it's really interesting because I think that most of attackers just scan buckets anonymously and receiving 403 forbidden message, thinking that they don't have access to the bucket. But if they were authenticated to their own, even malicious account in AWS, they would be able to retrieve some of the files and maybe even perform some actions, interesting actions on the bucket. And before we move to the scanning methodology, I want to clarify these two terms. It got us very confused during this research because, as you can see here, there is all users and all authenticated users. So which one of them is actually the authenticated user? So the all users group is actually anyone, anonymous access. And that's kind of funny because I don't understand why I call it anonymous access actual user. But let's just go with that. And all authenticated users is actually the predefined group that I've described earlier. This is any authenticated identity to the CSP. Cool, so how can you configure this misconfiguration in AWS? So of course you can do so from the portal, and you will have several warnings along the way that make you understand that you're now making the bucket public. And this is great because there are several warnings and reconfirmations that you need to do to really understand that the bucket is now public. This is the raw access policy, how it looks like in a JSON format. So as you can see, the principal AWS asterisk is all authenticated users. And by the way, if it was all users, it was just an asterisk without AWS. You can see the action and the resource that you can perform the actions on. And S3 buckets also have an older access model of access policy, which is ACLs. And you also configure it from the portal. The JSON format looks a bit differently, but it says pretty much the same. So the URI here, instead of the principal, here it's the authenticated users group, and the permissions is the actions that you can perform on the bucket. Okay, let's see how it looks like in GCP. So similarly, we have several warnings along the way while you're trying to configure public access to your bucket. And more specifically, when you choose the all authenticated users group, which is on the left side, you have a specific banner that says that now this resource is public and accessible to anyone who is signed into Google account. So this is good job, GCP. And also when you're proceeding to configure public access, you need to reconfirm that you are allowing public access. So this is really good. On the left side over here, you can see the raw JSON format of the policy. Again, the all-authenticated users group and the role that is assigned to it. But the most interesting part here is actually on the right side when I decided to check how you configure it from the terminal. And this time, you can notice that there are no warnings at all. So you should just think about it, that if you decide to go this way, you won't be warned at all that you're now configuring public access to your bucket. And if you want to check out buckets that you have and inspect their policies, you can use the AWS CLI command and also in GCP the gsutil and search for the exact groups that I've just described. So again, the principal AWS asterisk and see what actions and effect it has on the bucket. ACLs would be the URI of authenticated users, and GCP will be pretty much the same. Okay. Now, before we go to the methodology itself, let's see how usually attackers and bug bounty hunters perform bucket hacking. So the first step is, of course, enumerating bucket names. And as opposed to domains, I want to say a few words about that. Domains has like registration information if it's not redacted for privacy, and it's just more easy to know which domain it belongs to which like company or organization. And in bucket names, it's harder because it sits as a subdomain of the CSP domain. And yeah, but you have multiple open source tools you can use to enumerate bucket names. So you have the Cloud Enum tool, you can use the company name to filter out the results, and also the AWS I tool, which you can use account ID to also retrieve all related bucket names. And the next step will be, of course, try to exploit misconfigurations. So you can try to see if the buckets are misconfigured for the thing that we're talking about today, but also it is better if you check also just public access to all users. Okay, now that you've gathered a list of bucket names that you want to scan and test for this misconfiguration, the first step would be to scan them while you are unauthenticated. And the ones that retrieve 4 or 3 forbidden message indicated that you don't have enough permissions, you need to collect them and scan them again. The second time you'll scan them, you should scan while authenticated to the CSP and see if the response has changed to 200 OK. And the ones that did replace the response would be tagged as the misconfigured buckets. And for the results part. So in AWS, and I do want to say a disclaimer, we didn't scan all the buckets in the internet, but we did scan hundreds of thousands of them. So yeah, 96% of them at first glance seem private. And once we scanned them while authenticated, we discovered that 1% actually was public. And the majority of them, which is 63% of them, expose sensitive data, such as PII, bank account numbers, JWT tokens, SSH keys. We saw really a lot of interesting stuff there. And that just proves that this 1% is effectively public unintentionally. And this also, I mean, this 1% also looks like a tiny number, but since we scanned a lot of buckets, it ends up with huge numbers. In GCP, the pictures looks pretty much the same. So 98% of them at first glance seem private, and then almost 9% were effectively public. About a quarter of them expose sensitive data. And yeah, pretty much we saw the same things over there as well. Now, for the next question, how this happens. So first of all, human error. And I do want to say a few words about that. Because if you think about it, as a developer, you've launched a new bucket and you want to test authentication. So what you're going to do is first access the bucket anonymously, and you see that you're getting blocked, and that's a good behavior, expected behavior, while you're anonymous. And the next step, you're trying to test authentication and access the bucket while you're authenticated to your own AWS account, probably the one that you've launched the bucket with, and you see that it works. Authentication works, everything looks as expected. So it's really easy to miss this type of misconfiguration, and since you didn't scan your bucket from a foreign account, then you just missed it. So yeah, this is sad. All the rest are really pretty straightforward. So the copy-paste culture, so AI ships you also with misconfigured commands and old forms. You have Terraform defaults or just old templates that you just keep going, deploying this misconfiguration again and again. And overwhelming wizards, of course. You just want something to work, you click this and that's it. The bucket is public. And at this point, you're probably asking yourself, what about Azure Blob Storage? So fortunately, Azure is not allowing you to set this misconfiguration on their blob storage and containers. So good job, Azure, about this one. But we did detect the same misconfiguration pattern in a different Azure service, which is Azure SQL Server. Okay, so when you're launching a new SQL Server in Azure, you can start setting public access to it. You have the firewall rules over there that you can choose which IPs that can access to the bucket. Or you can go to the exception part in the bottom of the page and just click the allow Azure services and resources to access this server. Yeah, now, what I was thinking that just means that any service and resource in my environment can access the bucket. But when you hover this little one over there, you see any Azure service or asset. So come on, Azure. Why didn't you put the any just in the front page? It's just one word, you know? That would be even more comprehensive and clear for the user. And yeah, it effectively means that anyone that is creating a new account in Azure, which could be anyone, could start and expand and see the attack surface of your SQL servers. And maybe this example would be more clear. So I've launched a new one, a new database server, and I try to access in two ways. So the first one, I try to access from my own Kali VM hosted in AWS. I try to perform like this little password attack against my server. And I got this message: the client with IP address blah blah is not allowed to access the server. So in terms of access, I was blocked network-wise. I wasn't able even to communicate with the application layer of the service. But when I tried to access from a new account that I created in Azure, and I scanned it again in the same way, the response was changed to login failed for user SA. And yeah, this time I was able to infiltrate into the application layer of the service, and the attack surface just opened up to me. And in terms of like an attacker perspective, this is gold, because you see these servers that you can't communicate with them because your IP is getting blocked, and all of a sudden you have an attack surface, and I mean, this was an attempt that was failed, but now as an attacker, I can try and perform password attack against this SQL server. Okay, the results here are pretty awful. So again, we scanned hundreds of thousands of SQL servers, and 82% of them, while we scanned them from AWS, seem private, as they retrieved the previous message that my IP was blocked. But when we scanned them from Azure, we saw that 99% of them were actually public. Of course, we didn't continue and try to brute force users, but this is huge because it's just, you don't think that you have an attack surface to your databases, and 99% of them actually have. So at this point, you probably know where I'm going with it. So the same mistake is everywhere. And it started from S3 buckets, GCP buckets, and then we went and see that the same misconfiguration pattern in Azure SQL, so it can brought up to a lot of other services in cloud service providers. It can go to Lambdas and ECRs and Azure functions, and that just make me think that there are probably a lot of same misconfiguration pattern that we still unaware of it. So it's really interesting to start and digging and see what else we can get from it. Which leads me to the takeaways. So I try to perform a framework that ships you with instructions from the tactical to strategic. So the easy part is the discovery. So map your external attack surface and start scanning it. It's super easy. You just need to start scanning while authenticated and also unauthenticated, and also just scan it from multiple CSPs to see the diffs between the responses. And the next step would be, of course, the detection part. So you should inspect all of your policies in the services you host in a cloud, so you can identify the risk before anyone else. And finally, the prevention part. So shift left list privileges by blocking these risky misconfigurations within the CI/CD pipeline. So the misconfiguration won't even ship to production environment. Well, that was fast. Thank you for listening. You can check our other work from the Wiz.io research. This is where our old blogs are. And you have also the Threats Wiz.io, which is more focused on threat intel and actors and targeted technologies. And if you want to start scanning your resources today, we also have the repo over here. You can scan the barcode or just browse to this repo. And if you find more services that are misconfigured, you can also approach us and discuss it. That would be really fun to explore together. Thank you.